My name is Francesco Lovergine, and this notebook is taken from the presentation of the last year. A few things changed since the last year. Now, using from Python, the Google Earth engine is quite more simple. But anyway, currently there are some issues with the use of maps within the right. Just a moment. This one. Sorry, not infrared, but this one. Okay. And then
Yeah, something. Okay. Cerca di stare in quell'angolo.
Yes. Infrared not good. I said there are some issues currently in the use of the map system from Python. I think it is due to this notebook, in part to the use of this version of Jupyter that in the virtual machine. But I'm not sure because I have anyway some issues from Firefox with the current Jupyter lab, and so probably there's some fix that needs to be done in the package we will use to interface Google Earth engine. So first of all, in order to use Google Earth Engine, which is a cloud system dedicated to remote sensing application from Google, you need a Google account with Google credentials, and also being registered to the Google Cloud and to Google Earth Engine specifically. Generally, you need to authenticate yourself every time you need to use Google Earth Engine via browser. So it's not so nice to do that all times, but it's required by the strict authentication now used by Google. If you have a dual-factor authentication, you will need also this one in order to use the project, the cloud. If you know of use Google Earth Engine, that's almost 10 years of life. Did you use it in the past? Are you a current user of Google Earth Engine, at least at the console level? Yeah. No one? Just one. So just to show you something about that. Possible? It's working. Oh. Oh, right. All right, right. Share screen. And I think should I this one? Is it visible?
Yes.
Yeah. Okay. So whenever you try to access, you need to use your credentials. This is the dual factor authentication. And so this is the familiar, at least for someone, Earth Engine console. So for all other people, what is in practice Earth Engine? Is a sort of cloud for naive people dedicated to remote sensing and satellite, specifically satellite data. Here you can access a series of assets that are available in Google. Specifically, all of free satellite data are available for use in Google Earth Engine. You have a quite big catalog, which is accessible within the console. Yeah, your scripts and documents and assets, but you can add the data catalog. Yeah. So basically, it is a multi-petabyte archive, which contains all free data. That means the whole catalog of Landsat, the whole catalog of Sentinel, and all the data in the last, I think, 40 years are available if free of charge. So that means that, for instance, some satellites are not included in this catalog. For instance, Japan and other countries that are not available. But you have anyway a rich catalog of information, starting from a long time ago. So from 70s to current days, it is always up to date and includes mirror of the Copernicus information and many others. What I explain in brief is the sense that the use how you should use the Earth Engine. Because Earth Engine is a peculiar way of interfacing with those data. Essentially, you write scripts and programs that are written locally in your web browser or in a Python script, but you work with remote data. Specifically, this is quite important because when you write script in any type of languages, you always have to consider that variables visible within your browser or within your Python script are not those that you need to manage directly, because you need to manage instead data that are remote. So the local variables are not usable for the use of those kind of scripts. You always have to use a function that interfaces the remote data and get returns from there. And never use local variables. That means variables that are only visible within your scripts in your browser or in your Python scripts. The easiest way to use this system is using the console, which is this environment I'm showing here. You have in this section, in this panel, the script that you host on the remote catalog of on your own personal directory on Google Earth Engine. Those scripts are written in a language. This is JavaScript, Let me load one simple. JavaScript is a language used by modern browsers, at least in the last 20 years, probably. It's a C-like language, quite used. All these scripts run on your own browser. Result will go here in this area, which is which we call canvas, where you see sort of Google Maps with steroids. Here we will also load all remote data when they are processed or even when they are simply loaded on the system. The basic syntax of JavaScript is quite easy to use, but we will see in a brief how you can use to perform almost the same thing by Python without using a JavaScript console in this system. So you can write your own scripts and merging them along with your own scripts that use other packages or other numerical libraries for any goal you need. So you can work homogeneously in respect with what you have done until today. Let's see something very simple like this simple script, just to understand the sense of what is remote, what are remote data. Let's increase the font size. What's the sense of using remote data in respect with the local data? So you can see here that we use variables. So those variables are available locally. In this case, geo or Landsat or also composites are all variables defined in your browser, in this script that runs on your browser. But all those variables refer to calls to those functions, e.e. geometry point, e.e. image collection, e.e. algorithms, Landsat, simple composite, that are all functions that run on remote side. So geo in this case is a truly remote variable because it is the result of a function, geometry point, that creates, this is longitude and that's latitude, that creates a remote point in the Earth engine environment. More important, the concept of image collection. When you access remote data, you have image collection. That means a group of images available with continuity. So essentially, in this case, you are referring to the complete catalog of Landsat 8, and you are filtering the whole image collections all over the world by date, in this case, this range, and by simply proposing a bound. So fixing the area, the bound is the area, the footprint that this is your interest. You should consider that the whole image collection is the whole catalog of Landsat 8 all over the world. So you absolutely need to define a strict range for time and a strict area where you are going to run things. Also, you get results for the whole globe, which could be not of your interest. Okay. Here we are looking at USA, but we can enlarge and see the whole world. And the image collection are extended to the whole world, not limited to a single area. So when you run script, if you do not bound the area of your interest, your script will run all over the world. Of course, this could be not something of your interest, but the true power of Earth Engine is that it is able to run a single script over the world. By what? By simply defining different scales in respect with the native data. So when you run a script on the whole globe, you are running a script at the apparent scale of visualization, at the scale of your canvas. That means that even if you run this algorithm on the whole globe, it's not so computing intensive because it is computed at a different scale, not at 30 meters, should be for Landsat images, or 60 meters on the bands. And so the result could be also getting human time, not in a very long time. This is the power of the Earth Engine. So it is able to run script at a scale which is very different from the native one. So you can limit your interest to a single area, but you could execute the script on the whole area. And when I say image collection, I mean that. So it is the whole Landsat collection which consists in different frames spread over the world with different fingerprints and different dates. Whenever you run this kind of script, so let's run. The result. This is simply the composite of a Landsat, or Landsat 8 in this range. In this area, refer to this bounds. That means this single point. So it takes simply a composition of Landsat images along a year, in a range of 1 year, and compose all of them using the frame that is included in this, that includes these points. So typically this is a single frame, but in the reality, it is not only one frame, but it is a collection of at least 1 frame per month in this point. And it show with the simple algorithm, this is simple composite, the whole collection in this point for this the year required. Potentially one could also run this way. So removing the bound. And run again. It will take just a few times. Every time I change the zoom level, it will restart the computation, but it is composing the whole canvas with images for that year. And I could again zoom. And repeat the operation. It requires a bit of more time. But you should consider that we are composing the whole data set for the full year in the whole canvas. So for all United States instead of some little area. Of course, here there are some void areas. Here you can see that the layers is being composed, so it is completed. There was a banner that showed the level of composition. And the same can be extended for all over the world. exactly in the same way. So this is possible just because the whole catalog is remote. You are using many different clouds computer, not only one, and you are working at this visualization level. So the true resolution used in this case is quite far from the native or the true resolution of the data I'm using in this case, which is last. What kind of computation can be done in Google Earth Engine? Of course, you can use those kind of remote data, so you can use a lot of different data catalog for on satellites. But you could also add your own assets. The assets means that you can load your own image, and so use your image along with other data collections and perform different computation. The only limitation in this context, is about the quota dedicated to the user for his own assets. So you have 250 gigabytes of space for your own assets, and you should use that. Of course, the use of Earth Engine is free of charge, and even for the assets there is no charge. You can pay just in case you need to or find an agreement. Just in case you need more space for your own assets. That could be, for instance, your own private data, your own private commercial image, commercial satellite images, and so on. About the computation time, there are essentially there are no specific quotas that limits the number of cloud computers you can use to perform your computations. But of course, there are some limitations. When you run, for instance, at native scale, you can always find some type of limits in the number of pixels considered for some specific operation. So, for instance, if you run processing, but you need to get the result at native scale, you can you can export the result to your own disk. But this exportation, this exporting process is limited by the number of pixels that the system imposed to the user. So you can always find that exploiting the limit of Google Earth Engine could be at a cap, because it is impossible to run for all users any kind of processing with any kind of any size of the processing and the computation. That said, most of the system can be truly used via this. So, for instance, one can use the scripts and perform quite common operations, such as this one. I can export also this these maps just for along with the notebook for demonstration of the capabilities. So you can form quite common operation. The JavaScript syntax used is quite similar to a common object-oriented language, so it's not difficult to be used. Of course, you can refer to collections, but even to single image, and of course, perform operation that work on pixel, masks, and so on. In order to perform any type of operation, geoprocessing operation, quite common in the domain. The use of JavaScript language is not so difficult. It has the advantage of use of performing fast and to be accessible in a straight way. because the use of the console is quite immediate. It's not complicated at all. But of course, when you need to go with your own scripts and so working with other kind of data and exporting features or importing features, probably the proposed console in JavaScript is not always the best thing to use. About the type of function available here in the docs, in the documentation, you can see, for instance, that quite common algorithms are also available. So, for instance, classifications, even clustering and computation of confusion matrix, starting from classification, operation that work on with kernels, and so it's able to apply common kernels to images and perform all type of image operation. The less common part of the Earth engine is probably due to this kind of information that is, for instance, the operation of reducing. The reducing operation, as well the mapping operation, are common terminology used in H performance computing. The reducing operation are operations where you have stack of images, and starting from the stack, you reduce the whole stack to a single image of the same size of the same grid of the initial stack, with a single common result of operation that is a function of the whole stack, pixel by pixel. This is typically the reducing operation. The map operation instead is the same operation performed pixel by pixel for each image. So you get a stack and you return a stack again. This is a mapping operation. That's just to explain some terminology that can be used in documentation. In the area of the scripts, there are quite a lot of also demo scripts. A lot of documentation is available in terms of YouTube films, and many documentation is available that explain how you can use the whole system without great problems. And maybe just one part of the API of this system is based also on UI. For instance, you can write also script that includes forms to get choices by the user. So you can also write script where you do not need to modify high-end parameters and arguments for functions, but simply asking to the user by form, bars, and other useful tools that can transform this system in a sort of interface to the user UI. So it is quite useful also in that way, to simplify the access to those kind of algorithms. Now let's see the next step. That means how you can use all this via Python. Let me take this one. Starting from here, there are different ways of installing the required stuff, but basically, starting from 1 year, the main way to use the Earth Engine API in Python is simply by using pip. So you can install Earth Engine API, and that will install or even upgrade from time to time, and that will install this package, EE, and also all tools required to use your interface with Earth Engine API in Python just starting in from a notebook. Of course, the key point is that the Python interface do not include directly the possibility to have a canvas, but this is in any case possible, because you can use a couple of packages that use WebGIS interface. So you gain again the possibility to have a canvas by using third parties tool that are not part of the Earth Engine, but are part of other projects. These are FoilMap and Leaflet. The two kind of two clients used for writing on the client side the GIS interfaces. So whenever you install Earth Engine API, it is possible to execute again. In this case, you have to authenticate, and so via browser, you will need to generate your own token. The process includes, of course, credential and so on. You will get this token, which is passed to the notebook page, which is available here. So I'm copying the token generated once in the notebook page. All is okay. Seems not. That's all. If it's working, or if you need to restart the kernel, the HiPython kernel, I think, because this page probably has been too old. Yes. So let's restart this page again, because it's too old. Okay. Close this one. And execute. Again, the authentication. Okay, now successfully authorization is shown. That's that was missing. And this is the visualization. So basically, this is one basic user, because you have at least two alternatives to show maps. One is volume in the whole format, and the other is leaflet. Using Folio, you could also directly use the Google Earth Engine for Python without using third parties, any kind of third parties packages, and show, in this case, I'm just visualizing at those coordinates and start with a zoom of 10. The open which used on top of Google Earth Engine, it is able to provide other useful functions to add capabilities and features to Earth Engine as a base. You can change, for instance, using dmap, the map shown, as in this case. So this is the choice of a different map, but you can also create multiple maps, and even choose a different engine as for your map instead of the default leaflet. In this moment, this is the volume, which you can recognize by this layer panel. Generally speaking, GMAP gives some useful tools to integrate the canvas with other tools, so you can, as in the console, in the familiar console in JavaScript, you can draw and take a snapshot and so on. So, but for usual zoom in and zoom out. As in this case, but this is again the alternative use. When using the Python interface, the syntax used is quite similar to that for the Earth Engine part to that of JavaScript. That's because there's the same name of package. There are the same functions which can be used to access to image or image collection. Again, here in this case, NDVI in the local variable for the Python script, but those functions are all remote site, and so in this case you are computing the normalized difference among the two different advance of the Landsat 8. You choose your display palette, center the map where you are interested in. You can also, of course, use your own functions, as in this case. and show, for instance, in this case, the NDWI visualized over the provided Lancet image. In this case, again, you are using local variables, but essentially what you are really using are objects that refer to remote side objects and images and collections. So most of the operations, most of the processes is done on the remote side and not on in your own script. So you can also do zonal statistics, but one useful function provided by GIMAP is the possibility to translate a snippet of code written in JavaScript directly in Python. So you could take, for instance, a script taken from the console and convert it to a Python script by simply using this useful function JS_snippet_2π and so converting in a simple way. This cell has been generated by the previous instruction, so it is not written by me, but it is auto-generated. It also useful comments in order to understand what the whole script is doing. There's another example. Not shown in the map. No. If we have a look to this zonal statistics, you can see that using this script, you can at the same time create output to your system instead of using only remote data. Yes.
Does this snippet conversion also work the other way? Can I have Python?
From Python to JS, I don't think so. It is possible to output your own data. So in this case, you are taking SRTM dem and a single Lancet 7 image, and extracting also you are using the tiger boundaries and extract the stats state by state for the dem USGS dem, and output the result to a CSV file directly on your own system. Generally, this can be also done in the console, in the Earth Engine console, but typically it is done not directly on your machine, but on Google Drive, which is the common way of outputting data by using the console engine, which is quite different in this on those regards. Instead, in using this kind of stuff. Other functions are also quite useful because it is also possible to extract to perform the exporting operation directly within Python. So exporting in NumPy array and performing that in this way operation that can be done directly by your script once extracted the information from the Earth Engine directly to the final result. Of course, always applies the common limits, I say. That is, you need to consider how many pixels you are producing. So if you go out of the maximum quota for the pixel generation of big rasters, you have to find another way to perform this operation. Essentially, it's not possible to, but for specific agreement with Google about exceeding those limits, and so you have to cope with this factor, which is not always simple. Sometimes you need to perform operation, but you need to avoid them because they are not too intensive, and find another way to perform the same operation, or again find some kind of agreement. I think this is a simple tiny presentation of what are the possibility of using Google Earth Engine. I would avoid to present more details about that, but for eventually questions about those things. If you are not users of Earth Engine, it's quite difficult to get questions. But yeah.
I have a question for this GE map. So I tried to install it several times over different years. It was enough, but I never managed to make a Python environment that where I can install it. So it's always some problem. And I mean, it looks great, but when I see it on the back,
Platforms.
I was in the front environment.
Within common environment, the author suggested mini-conda for that. I never used mini-conda, but currently this is a simple installation of by people within my 3.10 installation on that. It's not a big issue. I find an issue about the use of those tools. I mean this one. The leaflet one currently has some issues. This one that creates maybe here and it's not more used indeed. This is yes, this is a volume. I avoid to use the leaflet. Oh, this one. This is the leaflet. It has a series of tools. This one, this panel. But it creates problem to the JavaScript engine. So it causes a session failure, and that break the kernel, the IPython kernel. So it is currently not usable. But for that, it is I don't find special problems in installation. Even if you have a look to the notebook on the last year, the installation was quite more complicated because you had to install the toolchain by Earth Engine before installing.
Yes, so this is what I was always following. So I was on the Google page and then installing the Google explanations, and after that, Google Map never worked. So I mean, Google works, Google Engine works, but GE Map, I was always complaining some package.
Under Conda, that would be possible. Windows.
Yeah, so I was having a Conda environment for Google Engine. Yeah, so.
But under Windows. So under Windows.
With yes, Mac. Yeah, I cannot be sure. Probably it was on Windows. Yeah. Yes, it was on Windows.
What on Windows? That could be an issue.
Yes. Yeah. But almost possible.
Could be an issue. It is quite usable, but for this part of the toolbox, it is usable under also the you can install by using simply this instruction. It works, but for the use of the tool, I say, so just by installing this, which is quite different from the past installation. So by pip install Earth Engine API, which is the Google part, and then installing Gmap, which is in the next section, I think, with this one, and possibly the notebook extensions, but it is optional. This is optional. I did not find any special issue currently. You have your computer here? Maybe it could be an issue on but of course, what is not working, that part of the JavaScript. But I think it's some issue because it needs to be updated for 3.10 or 3.11. That was developed. The start of development is in 2021. At that time, Total used 3.9. Since then, a few things have changed, but I think it's not. In any case, the author, which is a Chinese professor in the USA, is quite responsible. So we also asked him a problem about common installation, probably with some update for installing, and even the community seems quite large and responsible. And there are a lot of stuff provided. You shouldn't see. Another question?
Yeah, I was just wondering, so my guess is that your normal workflow is you do the mosaicing and then you have the processing in the web engine, and then once you have it like down to the smallest size, you can figure out and export it and do your models over there. And so this is rewriting that these Google gives you some contingents to work with. In your experience, is it better to do this at certain times of the day or the weekend when I don't know the US is asleep, or
I don't think so. It is used all over the world. So
yeah,
anything specific to it, well, let's try.
yeah. Like in the beginning of Google Code, that was a thing. Like when in Europe it was easier to get a graphics card access, but if you did it at night, you didn't because more users for that.
Of course, this project was born the Red Engine. So was born in 2015, I think, so almost 10 years ago. I think that now is still quite an interesting project, but it's losing the GPU interfacing, so the possibility to be more faster playing because of this missing part. But anyway, it's I find quite up to date for under many other aspects. Respect with the high performance processing, because it works by timing and distributing the computing load to many nodes. It's something that is still very actual, very up to date. It's something very interesting. Even it's quite good about the footprint of memory, but for the limitation that I introduced with scope, because they tend to solve, of course, these services, but it's quite fast and with very low limitation. If you know how to find a way to perform the operations, your processing, it's quite a good solution.
Well, last time I used Google Analytics about 3 years ago, when I was just doing it in the browser. And then I was doing some whole 30-year time series thing, and then each structure limits, I couldn't do it anymore. And then I opened another window and copied the rest of the code to the other window, and then it started, and then it ran. So I don't know, but I didn't really think why it was doing that, but maybe.
That could be some back and also face. I'm not sure about that. Generally, are not really issues in using the console JavaScript console. Of course, you have to respect the limits. I said, many people tend to work with attending as they work in local. So often, a lot of people try to export a lot of things, which is not the way to go. You have to perform most of your operation in remote and take just graphs and just a few results taken from the processing system. Never exporting to make things also. Of course, the major limitation is that if you miss an algorithm, you cannot implement your own. Essentially, because you have to work with the remote interface, and there is no possibility. If you need a random forest, okay, you have a random forest. If you need a SVM, you have a SVM. If you need another type of algorithm that should work on the remote side, and it is not available, you can't use that system. Simply, you can't think to download the stuff and perform operation and all because it's spoilers. You have to revert to another way to the workflows as such. You have to understand if your problem can be solved by using those algorithms and only, which is a approach. If you have no idea where is your final goal, and you have to discover during the path, you can discover that at a certain point that you can't resolve your math problem, the step Z starting from A, and you are done.
Because I don't know about for you is the concept of Docker.
Yeah, I suggest use of Docker for a simple. Generally, I suggest use of Docker for those kind of application. If you have a look here, you could also, because all these are notebooks or Jupyter Lab or anything like that. So you can put it. So you are running a web server within in your potentially in your own machine. So one way to solve your problem of compatibility is simply use Docker and piling up all required stuff you need to run any processing. So potentially, if you need to run some complicated environment that is based on a Jupyter notebook, you can prepare your own Docker machine, your own Docker image, and use that for your own personal use and to distribute also the result. So, for potentially to solve the problem that that guy had with his own computer on Windows, he could potentially use a Docker image and prepare a Docker image with a notebook and all the stuff, including GitHub, and use the Docker image on any computer that support Docker. So essentially, on any computer, we use Linux or Mac, and run the processing using only Docker, which is probably the next step the next year to solve some problems with the virtual machine and in this course, for instance, because now it is completely based on notebook on Jupyter. So potentially this could be a solution to have an environment that is independent from the hosting system. Talking about that, as a domain developer, I mean, developers that work on some specific domains you should think it in the first phase to how to prepare your own environment to run things and solve your own problems. The next step is learn to distribute your own solutions. And there are not many ways to do that. One way is using Docker. Docker is a bit constrained by the use of privileged levels. So if you are hosted on a cluster, a scientific cluster within a university, you have to cope with system administrators, and they do not like Docker. But there is Podman, which is the Docker for unprivileged users. And so you could potentially solve your own problems in some way. So you have your own environment, you create your own box, unprivileged, and you can run your solution even with colleagues on a scientific cluster by using those kind of systems. And so you avoid to work with environments, multiple versional languages, multiple versional packages that pull each other, and so on. I mean, in Python, but even other languages, and solve your own problems in an effective way. This is one way to approach this kind of things. I think also your problem with the mapper, you should simply prepare a Docker image with a base Linux system and use a Docker image
This Docker, I haven't used so far. It's like conceptually.
It is a container, which means something more light than a virtual machine, because it does not have a kernel. It's not a machine. It's a pool of processes in the base system that is used by your processes to run. It is an isolated environment. It is completely isolated. So you are your own Python interpreter, your own packages, your own system, your own ecosystem, and within that you run your own process.
But for example, when I build a container, I first install locally Docker.
You start from Docker and a basic image. A basic image could be like
Ubuntu.
yeah, Ubuntu, Debian system, Alma Linux, or whatever you like. Even those kind of there's for instance, Jupyter Teams distribute the SciPy notebook,
Yes.
SciPy notebook, or even other basic images. Then you have to add within those images add your own stuff and create a box that is derivative box that you can distribute and upload to an app.
So this is then a file. Yeah. So
Yeah, it's a single file.
it's a single file, and then to run it on infrastructure,
You just need to have a Docker installed. Yeah.
on infrastructure. And then this is and this is from command line repeat and apply.
Yeah, but now there's also a Docker for desktop. So you have an environment which is nice for people that are used to work with icons and windows, and you avoid also to use instruction like this one. This Docker pull simply install on your own machine the SciPy notebook, which is a Docker image. You run the Docker image in this way, and you have a Jupyter Lab complete, running on your own machine with all stuff in.
And for HPC, so we can specify the node Docker.
Yeah,
It would be local.
in the HPC, you will use Podman probably, not Docker, because Docker needs that in many scientific clusters it's not allowed, but you can use Podman. And Podman is run within an environment, in any kind of environment. You can run stack of software and that environment. It's the way to so for instance, when you do something like this, this is an example, you run the container with an interpreter, install things, here, make changes to your image, and then commit the new image.
And does it support GUI like so
It does agree.
okay. So it-
Basically, any Docker is the concept of Docker is giving the possibility to have service available. Service means any TCP port. So in this case, is 80, this one. But it's a general concept. You can, if you are able to provide service of any type, you can use a Docker image to build that this that service without dependency with the basic system. The basic system where you run things. That's all I think.